Just imagine a journey so vast, it makes the distance to the moon feel like a mere step. What if the very act of measuring the universe could transform our understanding of time itself? In this episode, we're not just climbing a ladder of scale, we're building a bridge from the familiar to the truly incomprehensible, one interval of light's journey at a time. There is a pleasure in measurement, a rare satisfaction in watching numbers unfold the invisible world into proportion. The light year gave humanity its supreme numerical tool, but numbers alone mean little without a sense of how they relate to the things we know. Understanding the cosmos requires that we build a ladder of scale, a chain of units linking the near to the far, the comprehensible to the incomprehensible. In this episode, we climb that ladder, one interval of light's journey at a time. We begin, as always, with the instant. Light moves 300,000 kilometers every second, the fundamental heartbeat of the universe. 1 light second is 300,000 kilometers. The distance between your fingertip and your eye when you snap your fingers is a fraction of that span. Yet within that single second, a photon could travel from Earth to the moon and 3/4 back again. When you imagine the moon suspended in the night sky, remember that its light is already delayed by 1.3 seconds. The shining reflection you see is not the present moment, but the echo of one already gone. Even this short delay has real consequences. During the Apollo missions, each conversation between astronauts on the lunar surface and engineers seated in Houston carried a 1.3-second pause each way. Every word took that long to arrive. Every reply arrived that long later. It was the gentlest, most practical proof that nothing, not even the radio signals of human confidence, can outrun light. Stack 60 of those seconds together, 1 minute, and the scale leaps ahead. 60 light seconds make 1 light minute, a distance of 18 million kilometers. Extend to an hour, 60 light minutes, and light has traveled 1.08 billion kilometers. Even at this early rung of the ladder, distances grow forbiddingly vast. Such numbers define the architecture of our planetary system. Earth orbiting at 8 light minutes from the Sun. Jupiter 43 light minutes away. Neptune about 4 light hours distant. When you check the weather and see the temperature of your day shaped by the sun above, you are feeling a star 8 minutes in the past. The sunlight falling through your window began its journey when you were still turning over in your sleep. If, a moment from now, our star were to vanish, Earth would orbit emptiness for 8 minutes and 20 seconds before realizing it had lost its anchor. Even the most immediate source of life is mediated by time. Scaling upward, 1 light hour, not a day, only an hour of human time, spans 1.08 billion kilometers. For comparison, that is from Earth to somewhere between Jupiter and Saturn. At this range, communication is measured not in seconds, but in signals delayed minutes or hours. The Cassini spacecraft, which explored Saturn and its moons between 2004 and 2017, operated at a signal delay of over 1 hour each way. Every image it captured, every command engineers sent, traveled 1.2 light hours through space. Control was an act of faith. Commands written far in advance, transmitted, then relearned from data arriving long after the moment had passed. If you're finding this journey through the cosmos as mind-expanding as we are, consider hitting that subscribe button and joining us for more explorations into the universe's incredible scale. 1 light day is 24 light hours, about 25.9 billion kilometers. At this scale, the yardstick of humanity begins to dissolve. The Voyager, one spacecraft, launched in 1977 and still whispering faint signals from the darkness, has traveled nearly 24 light hours from Earth after almost 5 decades in flight. It moves at over 17 kilometers per second, 60,000 kilometers every hour, yet in half a century, it has achieved a single light day of distance. What for photons is a fleeting heartbeat takes a human machine generations of persistence. Voyager's faint transmissions return to us after 22 hours of transit time, a full day of waiting for each reply. Voyager has crossed the heliopause, where the solar wind yields to the interstellar medium, a boundary marking the edge of the sun's domain. But if a single light day barely gets us to the edge of our sun's influence, what truly awaits us beyond this cosmic garden gate? What unimaginable distances must light traverse before it even reaches the nearest stars? But even there, only one light day out from our star, we stand merely at the garden gate of the galaxy. The nearest other suns are more than 1,000 times farther still. 7 such days make a light week, roughly 181 billion kilometers. Beyond this, one leaves not only planets, but personality. At a light week from the sun, its furnace would no longer dominate your sky. It would appear as a brilliant, star-like point, easily mistaken for any other. The planets of our home system would collapse into a single glittering cluster too small for recognition. Nothing of human origin has yet traveled so far, and perhaps nothing will for centuries. In these regions, solitude becomes physical law. Only the faint residue of cosmic dust, the remnants of comets, and the thin wash of solar particles accompany you. One light month, 30 days of continuous travel, extends over 778 billion kilometers. Standing hypothetically at that distance, you would observe the solar system reduced to a spark. Jupiter's orbit would be lost in the glare of its star. Saturn's rings would be invisible to the eye. The largest realm we call ours would now appear fragile and minute, surrounded by an ocean of emptiness. The light warming that distant vantage would be almost negligible. Beyond perhaps 1 billion kilometers, warmth itself becomes a luxury. Continue the climb. 12 light months, 1 light year, form the unit that has become the astronomer's chief measure. We have already learned that a light year equals 9.46 trillion kilometers. Place the previous increments together. 1.3 seconds to the moon, 8 minutes to the sun, 1 day for every 25 billion kilometers, and after 365 days of continuous motion comes 1 light year, the bridge between stellar neighbors. These gradations show more than magnitude. They show the way intuition fails. Each step multiplies distance by 60 or 24 or 7 or 30. Rapidly, it leaves human proportion behind. The acceleration of scale itself becomes a lesson. The difference between the moon's 1.3 light seconds and the sun's 8 light minutes is small in notation, vast in lived comparison. Likewise, the chasm between a light hour and a light day, or a light day and a light year. The brain is forced to surrender analogy and simply accept that space is structured in magnitudes exponential, not additive. We can chart this ladder numerically. 1 light second, approximately 300,000 kilometers, Earth-Moon distance. 1 light minute, approximately 18 million kilometers, 1/12 Earth-Sun distance. 1 light hour, approximately 1.08 billion kilometers, Saturn's orbital scale. 1 light day, approximately 26 billion kilometers, Voyager's realm, the heliopause. 1 light week, approximately 181 billion kilometers, beyond all planetary orbits. 1 light month, approximately 778 billion kilometers, interstellar approach. 1 light year, approximately 9.46 trillion kilometers, to the nearest stars. Each transition re-educates perception. By the time we reach the scale of years, every concept of near or far has been rewritten. On this ladder, the nearest star system, Alpha Centauri, resides about 4.24 light years away. That is not 4 distances added, it is 4 entire years of light's constant travel. To reach it by conventional spacecraft, say traveling as fast as the Parker Solar Probe at 192 kilometers per second, would require nearly 7,000 years. Each year of photon travel would become nearly 2 millennia of human effort. Distances of this magnitude are not simply unreachable, they challenge our vocabulary for motion itself. At first glance, this immensity might seem discouraging, yet it performs an important intellectual service. It compels humility. When you realize that sunlight itself takes 8 minutes to bridge the gap to Earth, you see that we live on a tiny island whose connection to the rest of the universe lies solely in the narrow, constant highway of light. Everything we observe, every image returned from a telescope, every faint radio signal is limited by that one speed and those layered scales. The ladder of light measurements is, in effect, the skeleton of knowledge. Astronomers rely on these increments daily. When the Perseverance rover on Mars transmits data, engineers expect round-trip signal times ranging from 10 to 40 minutes depending on the planet's position in its orbit. Communication delay determines the rover's autonomy. At Jupiter, round-trip time is over an hour. At the heliopause, 2 days. Future missions, if they venture to the Oort cloud or beyond, will operate unassisted, receiving orders perhaps months after events have already occurred. Where light takes weeks to arrive, forethought becomes the only form of control. By scaling through light increments, we also see the gradation of knowledge itself. Within a light hour, we are explorers. Our instruments can respond in near real time. Our engineers can adjust. Beyond a light day, we become observers, watching delayed messages unfold. Beyond a light year, we are historians, gazing at light older than our memories, collecting evidence of events already settled in the past. Each rung on the ladder defines a different relationship between humanity and the cosmos. Participation gives way to observation, and observation gives way to remembrance. The physical realities behind this ladder reflect mathematical simplicity. Because the speed of light is fixed, the increase of distance with time is perfectly linear. Double the travel time and you double the distance. What bends our minds is not the mathematics, but the scales to which it applies. In ordinary life, 1 second feels instant. In cosmology, it can be the difference between worlds. To experience that symmetry more personally, imagine shrinking the speed of light to a pace you could walk, say 5 kilometers per hour. In this slow-motion universe, the moon would be 15 kilometers away, about a 3-hour stroll. The sun would stand 90 million kilometers divided by our new light speed, or roughly 3 million hours distant, something like 350 years of walking. The nearest star, Proxima Centauri, would then be 18 million years march away. Compressing the speed changes none of the ratios. It merely makes the despair of distance more vivid. Space, it turns out, is not empty so much as vast beyond proportion. We occupy a pocket so small that all of recorded human history could fit comfortably inside the first few light hours around our star. Yet that pocket contains everything we have ever known. These scales also highlight a subtle truth. The faster we travel, the shorter the universe becomes in perception. As an object accelerates toward the speed of light, relativity contracts distance along its direction of motion. For a spacecraft somehow approaching light speed, the 4.24 light-years to Proxima Centauri would appear shorter to those aboard, perhaps only months of subjective travel, while remaining years to observers back on Earth. Time and distance, though separate in intuition, are married absolutely in reality. The ladder of light measurements charts not only space, but also the possible distortions of time itself. Climbing this conceptual ladder leads inevitably to the galaxies. From 1 light-year, multiply by 100,000, and we reach the diameter of the Milky Way. Multiply again by 2.5 million, and the light of the Andromeda Galaxy greets us, a neighbor whose image has traveled across 2.5 million years to meet our gaze. Each multiplication carries us farther into history. We no longer measure distance as a line, but as an epoch, a witness to how long light has been on its way. Understanding these progressions reshapes how we see even our own time. The night sky ceases to be static. It becomes dynamic, each star at a different depth of time. The faintest objects we can detect lie so many light years away that they show us the universe as a child only a few 100 million years after its birth. To scale the cosmos in light's units is to realize that the past still shines everywhere around us. And perhaps that is the true purpose of this exercise, not to memorize numbers, but to cultivate perspective. Measurement reveals more than quantity. It reveals relationship. The fact that a photon crosses the room in 10 to the power of -8 seconds, reaches the moon in 1¼ seconds, the sun in 8 minutes, and the next star in 4 years ties together every scale of existence into one continuum. There is no break between human and cosmic distances, only extension. So the ladder of light, seconds, minutes, hours, days, weeks, months, and years, is more than arithmetic. It is a guide for the imagination, a map by which we ascend from familiarity into magnitude. With its help, the incomprehensible begins to take shape. Some steps we can climb physically, others only with thought. But the climb itself is what unites us with the universe we measure. From here, the ascent continues outward, to the nearby stars themselves. Each glowing point in the sky becomes a milestone on this luminous scale. In the next episode, we will cross the narrow interstellar gulf to explore our immediate stellar neighborhood. The suns beside our own, their distances measured in light years, their light already en route before recorded history began. If you've enjoyed scaling the cosmos with us, make sure to subscribe for more incredible journeys. And to continue your exploration of the universe's wonders, click on the video appearing on your screen right now.